Welcome back as we move on to discuss how lubrication works. If we want to stop friction, we must somehow try and keep surfaces from actually touching or rubbing together. In practice, this is nearly impossible, as moving parts have to be connected together. Perhaps one of the most common moving parts on any machine is a bearing. Bearings are made in many designs, but in principle they are mostly used to support shafts and hubs so that we can obtain rotating components. This type of bearing is called a taper roller bearing, and we want to use it to help explain lubrication. This diagram shows how tapered bearings are used to support a hub. This is a typical wheel hub which supports a motor car's wheel. If we go back to our bearing, you will see it has a number of steel rollers, and when we put the bearing together, you will see that these rollers contact or come up against a metal face, which we call the raceway. What do you think is going on inside a wheel hub's bearings when the wheels are moving? Basically, the rollers would all be rubbing away against the raceway. But what we must first do is to put a substance in between the rollers and the raceway, and this we call a lubricant. The two most common lubricants are oil and grease. Both products are basically the same, except that oil is liquid, whereas grease is more solid. The main purpose of any lubricant is to get in between moving surfaces and, in effect, provide a kind of cushion to keep the metal surfaces apart. A simple way to help you see what lubrication does is to rub your finger hard onto any smooth surface. In a very short while, you'll feel the heat. Now, dip your finger into some water and rub again. Now you'll feel how smooth the action is. What is happening is that your finger is floating on a thin layer of liquid, which has dramatically reduced friction. In effect, you have lubricated your finger. Water is really not a good industrial lubricant because it boils away and it causes rust on steel parts. Instead, engineers have discovered that certain chemicals found in nature, called hydrocarbons, when blended or refined in special oil refineries, create slippery substances that can withstand heat, pressure, and do not cause rust. Today, we call these substances lubricating oil. If we go back to our hub bearings, lubricant, in this case grease, has formed a protective layer around each roller. This film of lubricant, although very thin, effectively keeps friction down to very low levels. A simple experiment can prove just how effective oil or grease is in reducing friction. These two metal plates have been filed and polished to provide smooth-looking surfaces. Let's rub them together without lubricant. Now, let's see our surfaces, which already show signs of scratching and wear. Now we'll apply some oil to another smooth plate. Spread it around a bit and do the same test. Right, let's have a look. We'll wipe off the oil, and as you can see, hardly a mark. Now, try and imagine what would be happening to all the moving parts in machines, like engines for example, if there was no lubrication. In actual fact, the engine wouldn't last 5 minutes before it would seize up, meaning that friction would have created so much heat, do you remember the grindstone, that the metal parts would literally melt together. Lubrication then, as you by now must know, is vitally important to all industries. Without it, industry would not be at all possible. After the break, we're going to learn about the various types of lubricants.